is Louis from Pythagoras theorem. As usual, we are to do the class for GSS2. Like I normally say, GSS2 should watch basic 4, 5, and 6, DS1, so that we serve as sort of a kind of refreshing them, and so it will serve as that for them, and it's very, very, very important. So, looking at it, we actually want to look at some simple laws. I call it simple law of indices. Simple laws of indices. So, this will be the second time this topic will be introduced. Number one, they introduced it in basic 5 and 6. So, and this is another time, the second time it will be what's introduced. So let me recall, like we normally do, a kind of recall on that standard form they did last. So take for instance, they say write 5,240 in standard form. Hope we know that this one without points means that the point is at the end. The point is at the end. So therefore, and we are going to shift the point to the first of the back of the first number, and this one will be shifted 1, 2, 3 times. So it's going to give us 5 points. You have shifted the point here. 2, 4. If you like, write 0. If you like, you write it as 10 raised to power. That's 3 is positive since you are shifting towards the side. And also, if I am given a 0.00045, so this in standard form will give me, I have to shift it to the first number other than 0. 1, 2, 3, 4, 4. So I'm shifting it 4 times. But when I shift towards this side, that's negative index. So 1, 2, 3, 4. That's negative index raised to power 4. And we now want to have, if you look at this thing, it looks like more or less like indices more. But if this is where you will know that it looks like indices when you are given to have, we need some application. But let's move forward. Let's just say some laws of logarithm, not like 3 or 4. Law of indices. Law of indices. Number one, like I said, multiplication law. Multiplication law. So multiplication law is when a variable is raised to power a particular variable multiplied by the same variable raised to power another. So what we do is that we just add their power. So this means that n plus n. So example under this one, like we normally do, examples under that, I'll even use this as an example. We have a raised to power, let's say 3, multiplied by a raised to power 5. A raised to power 3 multiplied by a raised to power 5. What we are saying is a in 3 places. A raised to power 3 means a times a times a. Now this times comes here. A raised to power 5 in a in 5 places. A times a times a times a times a. So if you count everything, it will be as if we have said applying the rule here that when it is multiplication, you add the power. So 3 plus 5, you know it's going to be a raised to power 7. Now let's put all this a together. It will not be 7. 1, 2, 3, 4, 5, 6. Oh, count all this, so it will be a raised to power 8, which will be the same thing. And that's how they get it. There is no any magic in the law. There's no any magic there. So let's go to law 2, the second law. The second law says, we call that one division. It's a division law. They call it all sort of name, but just get the concept. A variable raised to power a particular variable divided by the same variable raised to power another variable. So what we do is that this division will make you to subtract the power. So this will now be a raised to power n minus n. And of course, let's just see how it goes here. If I should say, let me give example. Now, let me say examples because I might not give more than one. So are we there? Yes, we have a raised to power 5 divided by a raised to power 3. So this peradventure, a raised to power 5 means a times a times a times a times a. I have 1, 2, 3, 4, 5 divided by a raised to power 3. So this division is the same thing as this. So uh, a raised to power 3, that's a times a times a. Now this a can cancel this a. This cancel this cancel this. It remains 2. So it's the same thing as saying a raised to power 5 minus a raised to power 3. Just subtract the power, which of course will give me a raised to power 2. And look at it, it remains 2 to a raised to power 2. So that is the second law. Let's go to the third law. The third law, which is very important here that you know, that we call it zero index. The zero index means if any variable is raised to power 0, it will be 1. That's that one. It's just like general law. Anything raised to power 0 is 1. So um, let's go to negative power. Negative what? Negative power. So we say negative power. It is when a variable has negative power, like this. So therefore, in this, the meaning of this is that this negative turns to make this one fraction. So 1 over this will now come together. So and this can turn to this anytime. It will be this to this, this to this. Example. So like I have a raised to power 5 divided by a raised to power minus 2. So here, solution, what this thing means is that a raised to power 5, I divide means I need to subtract. I need to subtract. So it will not be minus. But this thing has minus 2. Oh, this example will not even give me, but then let me solve this one. So minus times minus is plus a raised to power 5 plus 2. So this is a raised to power 7. Of course, this one did not give me exactly what I want, but then I let me see. Okay, let me solve it using this method and see if I will get the same answer. So a raised to power 5 divided by this one is the same thing as 1 over a raised to power 2. So this one is the same thing as this. So of course, it's going to continue giving me a raised to power 5. Don't forget that this one will be over 1, any number without fraction. And this division will turn to multiplication. Then this one will reciprocate. It will do what? It will reciprocate. So reciprocate means this will go up, this will come down when division changes. So a raised to power 2 over 1, this one 2 over 1. So this over 1 doesn't mean anything. The meaning is that it has now come to the first law, which is a raised to power 5 plus 2. That's a raised to power 7. You see, we got the same answer. So the laws there. So you can see that our answer is the same thing. So mathematics is interwoven. Now let me move to another level. Of course, can I give them one more? Okay, let me move to another level. I think they don't need it for now. Under examples. So examples could come in this way. If they ask us to like simplify or solve, we have a raised to power, no, let me say 3a raised to power 3 multiplied by 4a raised to power 4. So look at this now. They have coefficients. So what you do is multiply their coefficient. It will give me 12. So this A, I take 1A, then I add the power 3 plus 4. And this will now give me 12 A raised to power 7. So because if it comes in any way, so you just their coefficient, you treat them separate. Now let me now apply it to in this standard form. Let me apply it to standard form. Let's call this one 1. So I want to apply that indices to standard form. So let's say we have given 1.2 times 10 raised to power 5 multiplied by, let's say, 1.3 times 10 raised to power, let's say, minus 4. So look at this. The two are in standard form and they want me to give us a. So what I do is that this multiplication, I link it with this multiplication, deal with them. And this one, I link it with this using law of indices. Therefore, it will be 1.2 times 1.3 times 10 raised to power 5 times 10 raised to power minus 4. And therefore, I can multiply this one like we did in Latin primary 3. 1.2, 1.3, let's multiply. This one gives me 6. This gives me 3. This gives me 2. And this gives me 1. And that's 6, 5, 1. Where do I put my point? I count the number after the point. 1, 2. Then I count it from here. 1, 2. So my answer here will be 1.56. 1.56. So multiplied by this, I will now introduce that law of indices. Multiplication is in between. I'll add the power 5 plus minus 4. Plus, this one change to plus, like you say in the power, but this one is already minus 4. Then this one will be plus times minus. So it will be 1.56 times 10 raised to power 5 plus times minus minus. So therefore, and I have 1.56 times 10 raised to power, I think 1. So raised to power 1, I might not write it or I may write it. There is no problem there. But here is in standard form, so I don't need to do anything. But sometimes this answer will not give you standard form. So if the answer did not give you standard form, it means you still have to convert this one to standard form. So lastly, let me now go through this. Lastly, let's say we have 2.5 times 10 raised to power 6 divided by let's say is 0.5 times 10 raised to power let's say 4. Let's say 4 times 10 raised to power what? 4. Solve this. Let's quickly solve this. We have, like I said, I will link this with this and I link this with this. But don't forget it's division. As I'm linking them, I am dividing them. So 2.5 divided by 0.5. This divided by this. Multiplication is in between them. 10 raised to power 50 divided by 10. So you see that it's like everything that I have at top, this is at top. Everything, the second one, this is at down. It's still the same thing. Now, if I want to divide this, I do tell my student that it's very easy. When you want to divide decimal points, shift the point in equal proportion. So if I shift this one, I throw the point at the back once. I throw this one too once. That's all. So, and this will now be 25 divided by 5. Of course, this one division, like the second law, it will be 6 minus 4 according to the second law. So this one, let's divide 5 here, 1, 5 here, 5. So this one is now 5 multiplied by 10. This one is raised to power 2. So of course it's in standard form like this. So we don't need to bother ourselves. Like so this is our answer. Now I think let me give assignments. Let's look at this assignment for our case. Write 4,000 in standard form, 0.048 in standard form equally. solve this, division is in between, solve this, multiplication is in between, and solve this and leave your answer in a standard form. So do have a nice day, subscribe, and help us to share the video for people to know that mathematics is not hard but simple.